have a magnetic field that is uniform and pointing directly up. And we're going to consider 3 protons with the following trajectories. So here's 1, here's 2, moving in the same direction as the field, and then 3, there's our symbol for proton, moving the opposite direction as our first proton. And we're told that the field has a strength of 1/10 of a Tesla. The speed of each of these is 20 megameters per second, which remember is 20 times 10 to the 6 meters per second. And that we can find the force due to the magnetic field in vector form for each. All right, so let's look at 1 here. And because these are I almost forgot, because these are protons, they each have a charge 1.602 times 10 to the minus 19 coulombs. Okay, so for case 1 over here, remember our magnetic force equation is Q times V crossed into B, and so the first thing we want to do is figure out what V crossed into B is using the right-hand rule. Right-hand rule for this one tells us that V cross B is going to be out of the page. Out of the page. And then to find the magnitude, well, that's just going to be QVB times sine of theta, the angle between V and B. In this case, that's going to be a 90-degree angle, and so this goes to 1. And so QVB is going to be 1.602 times 10 to the minus 19 coulombs times our speed. I'm going to run out of room here, aren't I? 2 times 10 to the 7 meters per second times 0.10 Teslas. That, if you evaluate it out, is 3.2 times 10 to the minus 13 newtons after all of your unit conversions. And so for 1, it's going to be 3.2 times 10 to the minus 13 newtons out of the page. And we are done. And actually, if you think about this problem long enough, you're really done for 2 and 3 too, because 2, well, we have V and B in the same direction. And so V cross B, in this case, is going to give us 0. Because the sine of 0 degrees is 0. And so for 2, the force is equal to 0 newtons. No force means no direction. And so for 3, I'm trying to get all this on one page here. For 3, the only difference between 1 and 3 is the direction of V. And so now V cross B, the direction goes the direction goes, V cross B goes into the page, and so that's our direction. And if we look at the magnitudes, well, the magnitudes are all the same, right? It's a proton, so the charge is the same, speed is the same, magnetic field is the same, and so the only difference between 1 and 3 is the direction of the force. So this is going to be 3.2 times 10 to the minus 13 newtons, and we are going into the page. And we are done.